Today we're going to be answering some problems involving confidence interval. And for letter A, we're going to determine the point estimate, margin of error, standard error, and sample standard deviation given the confidence interval, the sample size, and the confidence level. And for B, we're going to give a statistically correct interpretation of the claim in this particular problem, which is our AA batteries last an average of 430 to 470 minutes, and our confidence in that interval is 95%. So let's go ahead and start problem number one. Or letter A. So we need to determine the formula basically, and we're going to do that backwards. So we know that the confidence level or confidence interval is given, and it's between 430 and 470. The confidence level is 95%, and the sample size is 30. So we're going to draw the illustration of this confidence interval so we can better visualize our work. So in this visual, if we have a normally distributed sample of 30, the confidence level is given by 430 and 470. And we're going to find the point estimate, margin of error, standard error, and sample standard deviation. So the formula for the confidence interval for t distribution, because the population standard deviation is unknown, will be x bar plus or minus t star multiplied by the standard deviation of the sample all over the square root of n. Now, we know that x bar is our point estimate, t star is the critical value, and this will be our standard error. Now, if we're going to work backwards, the easiest value to find will be the point estimate and the margin of error, because we have the confidence interval already. The point estimate is simply the midpoint of 430 and 470. So point estimate, which is in the confidence interval formula, is our x bar, will be the midpoint of the confidence interval. So 430 minus 470 divided by 2 will give us 450. So this is now our point estimate, so we can mark this off. Now let's find the margin of error. The margin of error in our confidence interval is the distance between the midpoint and the lower or the upper limit. So in this case, to find the margin of error, we just need to find the midpoint. So we already know that we have 450 as our median minus 470 will give us 20. So the margin of error is simply 20 because we are given the confidence interval already. Now, to find the standard error and the sample standard deviation, we're going to go with the formula, because we understand that if we multiply the critical value and the standard error, this will give us the margin of error. So if we're going to use that as an equation, we'll be able to produce the margin of error equal to t star Sx all over square root of n. And in this case, we need to find t and Sx to be able to find the standard deviation and the margin of error. And this standard of error will also be found using this particular technique. So t star, or the critical value, can be found using the formula 1 minus the confidence level divided by 2, and that will give us 1 minus 0.95 divided by 2 is 0.025. 0.025. So this will be the value that we're going to be finding to find the t value at 0.025. And using our calculator again, so we'll need the vars function or second vars function given the distribution. Go to inverse t and you'll find 0.025, so I'll already have it here. The degrees of freedom will be sample size minus 1, which is 29, and those are the only two things that we need, 0.025 comma 0.29, to find our critical value, which is negative 2.045, and we always use the positive value of the critical value, so we'll use 2.045. So now that we're getting closer to our answer, let's go ahead and plug in the equation and see if we can solve our equation. So our equation, the margin of error we know is 20, equal to the t star, which is 2.045. We don't know the standard deviation of the sample, and we're going to find it using algebra. So n is 30, so we can also plug it in. So now we're only missing Sx, and by algebra, so first let's get rid of square root of 30 by multiplying both sides by square root of 30. So this cancels out, leaving us square root of 30 times 20 times Sx. And by dividing both sides by we'll have our Sx. And with our calculator, square root of 30 times 20 divided by 2.045 is 53.57. And 53.57 will be our Sx. And Sx is the sample standard deviation. So we know what the sample standard deviation is. We're just looking for the standard error now. And we know that the standard error is Sx all over square root of n. So by using our values, SE, or standard error, is Sx all over square root of n. So Sx is 53.57 divided by the square root of 30. And it will give us 53.57 divided by square root of 30, 9.78. which is our standard error. So this is how we work backwards given the confidence interval and the confidence level of our confidence interval, and then we're working towards finding point estimate, margin of error, standard error, and standard deviation of the sample. Now to answer problem letter B, we need to give a statistically correct interpretation of the claim. To do that is when So that's how we interpret the confidence interval statistically. That if we take a repeated sample of 30 batteries, we are 95% confident that the true mean lifetime of the AA batteries will be captured between 430 and 470 minutes.